Hello class, in this video I will be discussing the properties of definite integrals and then using the fundamental theorem of calculus to evaluate a definite integral. Let's begin. There are 5 properties here, and the first one states the definite integral from a to a of f of x dx is equal to 0. And what does that mean? Well, if I draw a function and label it f, and then place a vertical line from f to a point A, the area of that straight line is 0. Property number 2 is the constant multiple property. It says that if the constant multiple is inside the definite integral, we can evaluate the definite integral first and then multiply by the constant multiple. Property number 3 states that you can break a definite integral up into its smaller parts. So if you have the definite integral of the sum of or difference of 2 different functions, then you can break it up into 2 separate definite integrals. And this property holds for 2 or more functions. Property 4 states that you can break a larger definite integral into a smaller definite integral as such. So let's say that I have this function here, we'll call it f of x, and we have this very large area here. Well, if I place a value c right there, then this definite integral will represent the area between a and c. This definite integral that I'm highlighting in blue will represent the value of the area between c and b. And if you add those two areas together, that will be this definite integral that I just highlighted in purple. Property 5 deals with the direction in which you find the area. So if we want to take the definite integral from a to b, that is equal to negative times the definite integral from b to a. So going back to the previous property, if we were to calculate the area from left to right, this area would be positive. From right to left, the area becomes negative. And that's what property 5 states. Okay, so now that we have the properties down, let's use the fundamental theorem of calculus to evaluate a definite integral. It states use the fundamental theorem of calculus to find the area between the curve and the x-axis of the following. So the definite integral is negative 1 to 1 of 3 dx. And the fundamental theorem of calculus requires a continuous function. So is f of x equal to 3 continuous? And the answer to that question is yes. f of x equals 3 is a constant function. Therefore, continuous on the interval -1 to 1. Okay, so now we are ready to apply the fundamental theorem of calculus. This expression right here, the 3, that is going to be f of x. And the antiderivative of 3 is going to be 3x. And we're going to label this capital F of x. And we're going to evaluate capital F of x at the two endpoints, 1 and -1. So capital F of 1 is equal to 3 times 1, which is 3. Capital F of -1 is 3 times -1, which is -3. So this is equal to capital F of 1 minus capital F of -1, which is equal to 3 minus -3, which is equal to 6. So the value of this definite integral is equal to 6. And why is the value of this definite integral equal to 6? Well, over here to the right, I sketched the function y is equal to 3. And since this function is completely above the x-axis, all of this area is going to be positive. And this is a shape that's pretty straightforward to find the area of, because this shape is a rectangle. And the distance from -1 to 1, this distance is 2, and the height of this rectangle is 3. So the area of the rectangle is equal to 3 times 2, which is equal to 6. So the area in red plus the area in green is, well, there is no area in red, so it's just the area in green. The area is 6. So that is why the value of this definite integral is equal to 6. And that's because the area of this rectangle, which is the area between this curve and the x-axis, is 6.